Welcome to the WION podcast. You know, forever we've looked up and wondered, are we actually alone out here?
That fundamental question, yeah.
And today we're diving into something really exciting related to that, the hunt for habitable water worlds right in our own solar system.
Because the guiding principle, really, for astrobiology has been follow the water if we find liquid water.
That's the key ingredient for life as we know it, right?
Exactly. So the big focus now is shifting towards these icy moons out past Mars, orbiting the big gas and ice giants.
Like Saturn's Enceladus and Jupiter's Europa. Those are the famous ones.
Those are definitely the headliners. And the reason is we think they might have these enormous oceans hidden away.
Hidden under, what, miles of ice?
Potentially, yes.
Yeah.
Thick ice crust that could, actually protect whatever's underneath from radiation and the vacuum of space.
Okay, so potential oceans, protected, but hidden. How on earth do you find something like that? You can't just, point a camera down.
Yeah, no. That's the challenge. Your standard remote sensing, your cameras, your radar, they can't see through that much ice. It's too thick.
So what then? Are there other ways?
Well, yeah. Scientists are getting clever. One really promising avenue is magnetometry, studying magnetic fields.
Magnetic fields? How does that help find an ocean? Seems a bit indirect.
It is, but magnetic fields have this useful property. They can pass through solid stuff, like ice.
Oh, okay.
And if you have a big body of electrically conductive liquid like salty water, an ocean moving within the planet's or moon's main magnetic field.
It does something, creates its own little field.
Precisely. It generates its own subtle secondary magnetic signature. So by measuring the total magnetic field very carefully, you can tease out that signature. It's a bit like an MRI, using magnetic fields to see inside.
Okay, that makes sense. A magnetic fingerprint for a hidden ocean. Cool. And I hear there's some new tech making this even more feasible.
Yes, that's right. There's been a real breakthrough with solid-state quantum magnetometers.
Quantum magnetometers. Sounds advanced. What's the advantage over the older methods?
Well, several big ones, actually. They offer really competitive sensitivity, so they can measure those tiny magnetic signals we're looking for.
Okay, sensitivity is key.
But, crucially for space missions, they are much smaller, lighter, and need significantly less power.
That's always the bottleneck for space stuff, isn't it? Size, weight, power.
Always. But there's another really neat feature. They can self-calibrate.
Self-calibrate? How?
It uses a quantum interaction, basically between atomic spins, and lets the sensor constantly check and correct itself for drifts over time without needing commands from Earth. Think of it like a built-in reference point.
Wow. Okay. That's incredibly useful for long missions far from home. So bringing this all together, tiny, sensitive, low-power, self-calibrating magnetometers, what does this mean for, the actual search?
It could be revolutionary. It potentially allows us to downscale the kind of instruments you'd normally need on a huge, expensive flagship mission.
Like the billion-dollar ones, yeah.
And put them onto much smaller, cheaper platforms, like CubeSats, those little toaster-sized satellites.
Seriously, so instead of maybe one big mission every decade, we could send out a whole bunch of smaller probes.
That's the potential, yes. More shots on goal, basically. You could really accelerate the exploration of these moons.
So this quantum tech isn't just an incremental improvement. It could actually open the door to finding these hidden oceans much sooner, a whole new way to explore.
It really could be a game changer for understanding potential habitats in our own solar system.
Amazing. It feels like we're getting closer to answering that big question. Well, that's a fascinating glimpse into how we might find these hidden water worlds. Stay tuned for more such intriguing stories to come on the WION podcast.